Thank you.
You're welcome. Okay, now if you're looking into this circuitry, very simple thing. I get U1, U2, U3. First thing, we're talking about U1. What U1? Just the
Buffer.
buffer, okay? The buffer that's telling you, okay, just I want to get this thing here. Okay, the buffer means pin input, pin 2, they will be the same with output pin 18. Pin 4 and 16 the same, 6, 14, same thing, 8, 12 will be same thing. If pin 1 must be ground. That means if you get a logic 0 at pin 2, then pin 18 will be 0. You get 1 at pin 2, then output 18 will be 1. That's a buffer, okay? Input output will be the same if pin number 1 will be enabled. That will be same thing for U1B. Whatever on 11 will be go to pin 9. 13 go to 7, 15 go 5, 17 pin 3. If the pin 19 must be routed, nothing else. Okay? Then we try to see on this guy U3 here. This U3 is just a D flip-flop. Okay? Preset connect to 5 volt. That means nothing to do with the preset. However, clear here will be connect to clear of the U2 and also connect to PD pin number 1. And what happens if pin 6 not kill connect into pin 2? How they be working on U3A?
D becomes not Q on each positive clock transition?
No. What I'm saying is not Q connect back to D. Okay? Then we try to see how this IC working in this connection. First thing you understand, D flip-flop very simple. You get a clock, then Q equal D. It's it, nothing else. No formula. However, if they connect not Q back into D, then how did U3 working?
Well, first, PD1 sends a 0 to U3-1 and U2-1 and make clear 0. And then you told us when clear is 0, the output is 0 no matter what.
Which means not Q is 1
right,
under those conditions.
Right, go ahead.
It's not what I want. What I want to asking you, when they connect not Q back into input D for the D flip-flop. So how did flip-flop working?
Yeah, that's what we get into. Then you eventually, the clock will go and it'll toggle.
Exactly. That means whenever you see the not Q back connect to the input D, then this flip-flop will be toggle every time they get the clock transition. If it was 0, when you get a clock, they go 1. If they 1 output, if they get a clock coming in, they will be go to 0. That means keep toggle.
Right.
Okay?
Right.
That is the U3A working in this lab. Last one, U2. U2 will be we call a BCD counter. binary code decimal. Okay, that means they are binary, but they working exactly the decimal. And the decimal only start from 0 up to 9. Okay, cannot go to number 10. BCD don't have a number 10, 0 to 9 only. Okay, and then this is a BCD counter, and we can see how they working. Okay, now in order to understand how they working, and really you need to know how to deal with timing. Okay, on the timing here, okay, you can get the clear right here. How do, if you want to apply, want to clear the flip-flop, what logic on this clear?
0.
0 right here. Okay, and from here you're going down. Okay, you're going down here. You see the output here, right?
Right.
But the output here is not telling you anything. That means they're not working yet. You see that?
So when you see those little lines like that, that means don't care.
Yeah, those don't care.
Okay.
When they normally they have to telling you 1 or 0, right?
Mm-hmm.
However, in here you can see nothing at all. That means they're not working yet. Okay. Now you can see this is the clock here.
Mm-hmm.
Only when the clock going 0 to 1, then the output will be 0, 0, 0, 0. You see that?
Right.
So that will be telling you for this IC, the clock controls everything. You want to clear, or you want to load, or you want to count, they asking for at least you must get the clock going 0 to 1. That's what they call a synchronize. Without the clock, they're not working. If you apply the clear 0, they're not working yet until you apply the clock going 0 to 1. Then output will be 0. Okay? And now another function, they want to load it right here. If you want to load, the apply logic to load will be 0, right?
0.
Okay? They will be 0. When the clock 0 here, and make sure your clear must be
1.
1. Otherwise, you cannot load it. Okay? Now, you're going down. A1, B1, C1, D0, that means number 7, right?
Right.
0, 1, 1, 1. And you're going down here. Okay? Right at the 0 here, you're going down. Output still 0. You see that?
Mm-hmm.
After you clear, they not get the number 7 yet until you get the
Clock.
clock. And after you get the clock going, output will be 1, 1, 1, 0. That means number 7. They're telling you, you can load in any number less than 10. However, you apply to input A, B, C, D in order to clear, in order to load, then load must be 0. And also clear, make sure they have to be 1. Then you apply the clock and output will be loaded. Okay, so you can see that loading, they also require the clock transition. And then now they will be stuck, okay, counting.
Mr. Pham, just real quickly before you go, on the ENP and the ENT for load and clear, they're both low, but what does ENP and ENT actually do?
Basically, that will be enable for counting. If you want to counting, that have to be 1. The thing A and B, okay, or A and T here, okay, when you loading, they supposed to be 0. When you clear, they supposed to be 0. However, when you start counting, they must be
1.
Okay. So now they will be number 7. And if you want to counting and you start apply the clock, they count to number 8. Okay. Then they count to number 9. After count to number 9, they go back to number 0. Okay. That means they counting 0, 1, 2, 3, 4, 5, 6, up to 9, go back to 0 and keep going. Now, let's see, you can get RCO. That means the output. Okay. That means carry out. They will be normally 0. See that? When they go high.
At the end of the count?
Okay.
That's what provides your positive clock transition for U3.
They going high when? If you're looking up here, when that will be 1, 0, 0, 1, that means number 9, right?
Mm-hmm.
When the counter reach number 9, output going high to let the people know we already done for one counting sequence. They count 0 up to 9, and after 9, they go back to 0. Okay?
So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. Then it pulses up to 1, then goes back to 0, and then it goes 0, 1, 2, 3.
So if I'm looking on the timing, I see RCO here. When they go 9, I know for sure the output will be 1, 0, 0, 1. They just let the people know what they done for complete cycle. Okay? When you start count 0 up to 3, 4, 5, 6, they not go to 1 until output go to number 9. Then they go here. Okay? That's a very simple thing.
Hey, Mr. Farrell, and the last thing on that, what was that inhibit part?
What
The inhibit, down the bottom to the right.
inhibit part here, they don't care. That means they keep going 3, and they don't want to draw more. Okay?
Okay.
So that's why they don't care on this thing here. That's why they ignore it. Okay?
So it stops at 3?
No, it's not stop at 3. They can go to 4, 5, 6, up to whatever. But they don't want to repeat it.
Oh, that inhibit mean they don't want to repeat.
Right.
Okay, all right.
Now, first thing, if you want to clear, you apply 0 here. 0 here will be clear U2. Q A B C D here 0. Okay? And also 0 here, clear U3. Pin number 5 will be 0. Okay? That means the clear. So if you want to do the clear, you say apply PD 01 is 0. Okay? And the next thing is they not clear yet until you must be applied the clock, P clock for U2. Then they verify pin 5, 4, 3, 2, 1 is 0. That is testing for the clear. Okay, so now if the clear fail, if you're looking on the output coming out, you know which pin will be failed. For example, pin number 5, they're supposed to be 0, but they're not 0. So that means something wrong with U3A. So what you need to checking, you can checking, make sure pin 1 must be 0. Okay, and also pin 4 must be 1. If you not get 0, pin 5, then U3. And now if you fail one of the pin here, then you can make sure you take 14, 13, 12, 11 supposed to be 0. Okay, if they not, then you have to make sure pin 1 must be 0. And also you have to make sure pin number 2, you get the clock transition 0 to 1. Okay, if you already get pin 1, 0 and you get a clock here, then you do.
The load's got to be 1 too, right?
No, we don't care. Clear equal 0, you cannot loading anyway. They can be either 1 or 0.
But you like to put a 1 there since it was 0, correct?
You mean on the load?
Yeah.
Yeah. Normally you don't want load, then you can put a 1, but I said clear higher priority. They override the load.
Correct.
Load 0 or 1 doesn't matter.
Mhm.
That's why for troubleshooting on this test, I telling you, you make sure pin 1, 0. That's the first step. Second step, make sure you get a clock going 0 to 1 at pin 2. If you get both and output is not right, then you do. That's how we troubleshooting. And now, when you check output 11, 12, 13, 14, QABCD, you get the right data. You get a 0 here. However, output here do not get that. For example, pin 9 supposed to be 0, they are 1. Then you go back to pin 11. Make sure pin 11 be 0. And you get a 1 here. And what next you have to do is check pin 19. They must be 0. If they 0 and the input output not the same, then you 1.
Right input, wrong output.
That is the troubleshooting.
Mhm.
It's not to say that IC not working. You have to prove you get a right input, but you not get the right output. For any analog, electronic, or digital, same thing. Okay? Then now you can test for loading. Loading, that means you apply, okay, A, B, C, D right here. 0, 0, whatever they want here. In here, let's see.
They start out with load 5.
Okay, they loading number 5, number 9, right?
Mhm.
Number 2. Okay. Loading number 5, that means you can get 0, 1, 0, 1 apply from PA. Then you may, at the output here, you can get the same 0, 1, 0, 1. Okay. Next step, make sure you have to get pin number 1 here, PD01 have to be logic 1. Okay, and also pin, let's say, load PD02 must be 0 to load.
Mhm.
Okay, NTNP will be 0, 0. And you must get the clock going 0 to 1. That will be bring up to this point, 0, 1, 0, 1. If you get that, you measure right here. If you not get 0, 1, 0, 1, okay, then you have to go back to C. QA go with A. What pin C equal? If pin C equal 1 and PA not equal 1, so that will be the problem with the U2. Okay? And if you get a right at the QA, then you must be take U1B11. Normally, in the company, you don't have to check this way. You don't have to, you take 14, you don't have to take 11. On the lab, you have to do the thing is the wiring, maybe you connect wrong. Okay? In the company, you check QA logic 1, then you can go right here, pin 9. Supposed to be 1. If they not 1, that means U1B can be wrong. Make sure pin 19 must be 0. And that's the same thing for different load. You apply input here, they go into input U2. Okay, you apply the load, then they go here, and they go in here. And the last part for counting. If you want to counting and you can guarantee you make sure the output must be 0. Okay, and I try to see on the port in here. Okay, they load. Okay, then they test the clear here. That means they test the clear before they want to load, right? Or to counting. You can see right here, test the clear right here. That means they guarantee the output of the counter will be 0. And also the clear for U3 pin 5 also will be 0. Then now they will be start counting up 1, 2, 3 to 7, 8, 9, 0. And after you count up to the 9, okay, and to 0, then the flip-flop U3, they have to be toggle. Then it have to be go to 1. Okay. So for the counting, first thing you must be apply the clear. Guarantee the output here will be 0. Guarantee this guy will be 0. Then now you start make sure D pin 1 must be 1 before you start counting. Make sure load pin 9 must be 1. Okay, and also NT and P they also be apply 1. Then you apply the clock. One clock they counting 1 number. Okay, so will be 0. The apply clock they go to 1, 2, 3, 4 up to 9. When you get up to 9 in here, the output here they will be toggle. Okay, the reason is why we have to do that way. If you're looking at the timing right here, this only going up for a very short time, then they going down. If you're doing a testing manual, that's okay. In a manual, that means you have to connect the oscilloscope into output RCO. However, if you're using oscilloscope and that scope must be stored scope, okay? Stored, that means you set it up when it's going up to 1 and the scope gets it. They keep that picture for you. Otherwise, if they not stored, when they're going up and they're going down, you never see. That's the manual testing. However, in here, I have to using the D flip-flop. First thing, I make sure the output 0. That means you don't have any positive going here, any pulse coming until they get number 9. And they go up to 1. That will be the clock for this guy. And this must be toggle. So if I say this toggle to 1, I know this output will be working. So basically, not you must test a thing like that on the count up, no count down. Okay. And here, that only let's say you can get up to only 15 taps. Very simple.
Hey, Mr. Pham.
Yeah.
You know what? On test number 4 and test number 15, she didn't ask, but Kumi had asked me about this. How come the mass data on number 4 is 1F, but on number 15 is 10?
Okay. Now on that number 4, they want to make sure when they clear, output counter have to be 0. Right?
Test
Right.
15, they're only worried about U3, that's why.
Right. I'm talking about that 4 first.
Right.
On that 4, you clear, and you want output have to be 0, 0, 0, 0.
Mm-hmm.
So that's why F.
Right, because you got to worry about U3. Okay,
Right.
but
And
then,
big one U3 here, they also make sure they must be 1. You see that? I1 counter U2 must be output must be 0. And also I1 U3 output make sure 0. So that's why math data have to be 1F.
okay, now go down to 15.
Okay, now going 15 here. Basically, I just want to know, is it that U3 pin 5 worth 0? Is it they go to 1 or not?
Mm-hmm.
I don't care about that guy.
Mm-hmm.
This guy already done up to 9 and 0. So that's why I ignore. Okay?
Mm-hmm.
Don't care about what the output, doesn't matter to me. But I'm
Let me ask you this then. Let me ask you this. And I'm just asking.
yeah.
Those for where you got those 4 X's at, could those be 1s for the purpose of mass data?
No, when I say don't care, that means I don't really want to know what's going on here. So that's why they must be 0.
For the mass data.
Right.
When you have a 0 in the mass data, it means that you're not paying attention to those pins.
Right, exactly. That means I ignore it. They can be either 1, 0, doesn't matter to me. But
Okay.
I don't need that.
Okay, guys, got it. I hope Kumi got that because she asked me about it.
Yeah, she can ask me.
Hey, Kumi, say something.
Okay. I understand the expect data, but mass data still zero.
Okay, now I can tell you one thing. Mass data, what that mean to you? That means if you care, then you have to get that number.
Uh-huh.
If you don't care, then you put it 0. Math means and. That means whatever they read, they take that and with 0. Then they can be 1 or 0. They end with 0, they still 0 anyway. Okay? On this one here, I can tell you. Okay? You want output of the counter have to be 0. So that's why you have to match with 1, F, with F. Also, I want this must be 0. So that's why I have to end with 1. That's why you get 1F.
Okay.
Okay? And now when you start counting up, I mark only F. That means I don't care on here. I only care on this part right here. That's why F. Okay, when you go into up to here, that means they already counting good. I don't care anymore. However, after finally this bit here, I really want to know is it they go 1 or not 1. So that's why I mark with 1.
You want to know if U3 toggled from 0 to 1, and those other bits you don't care about them.
Right. That one we already done for the counting. So no matter what bit in here doesn't matter to me. I just want to see this guy, is it 1 or not 1? Okay, now the thing is I want to ask you guys. That means I want after they count up to number 9, and this will be go into 1. All right. At the beginning, they will be 0. And after they go up to number 9, they go to 1. If they not go to 1, what caused the problem? That means I'm talking about PCOM.
If it doesn't change to 1, you're going to want to check pin 3 and your RCO, pin 15 of U2.
Yeah, but the thing is right now, if we're not talking about troubleshooting yet, okay? I just asking about PCOM for verify output here to be logic 1, test 50. What the PCOM?
U2 and U3.
Okay, U2
Yes.
and U3. Now, why you say U2?
Because the clock transition for U3 relies on pin 15 from U2.
Exactly. That means if U2 they not sending out the clock, right? Then it's not working, it's okay. That's right. Then they must be get the pulse coming out here in order to apply the clock to U3. Okay? So if you get this one, and also if this U3 not working, then this will be not go to 1. For example, you're missing the wire from pin 6 to pin number 2. Then they cannot toggle. So that will be U3. Now, how do we troubleshoot? To isolate either U2 or U3. How do we troubleshoot it? To isolate U2 and U3. U2 problem, or U3 problem? Who can tell me? Ah, who knows? Tell me. If I want to isolate U2 and U3
Do
on
you have to disconnect the clear or something?
no,
Okay, the
Would
other
you
guess,
just-
the
would you
other
just ma-
guesses are pin 15 U2.
Yeah, would you just measure for the pulse at pin 15 of U2, and if you're seeing it at pin 15 of U2, U2's good, then it has to be U3 that's the problem.
U3, yes, that's correct.
that is the correct way. However, in the test program, okay, I can tell you how can we do. You can connect the scope into U2 pin number 15, right?
Yes,
When you run it. And you understand it, pin 15 will be 0.
that means the U2 got no output.
No. Why they run? 0, 1, 2, 3, 4, 5, 6. Then this have to be 0. Right?
Right.
When they go 1,
That's at the completion of the count. When it gets to 9.
okay. They tell you when they get to 9. This must be go to 1. Correct?
Mhm.
Yes,
Okay. Now, if you know how to do, you have to set the breakpoint. Okay?
The what? The breakpoint?
Yeah.
He's talking about debugging on the computer.
Debugger.
Oh, okay.
Set a breakpoint at the start of test number 15. So while they running, you can looking into the scope, you can see the 0. See that?
Mm-hmm.
However, when they go to start at the 15, they stop. They stop, you want to keep going. I take you to the next line, you have to press F10, right? When you press F10, they going to what? After you press 1 or 2 times, depending on how many steps on that.
It counts up until count to 9.
Yeah, that means they count to 9. That means
You
pin
going line by line?
15, yeah, line by line. That's the debugger. Then you can see they go to 1. Then you know nothing wrong with U2. Only thing now you deal with U3. Engineer or technician, software. Anyway, everyone have to know how to working with debugger. Without debugger, you cannot do anything for troubleshooting. I do the same thing you guys doing. When I build the circuitry, I run the test, they fail. That's why I need debugger. Without that, I can not fix the circuitry. The thing is when I try to design, I think they're working that way. Maybe not. And also maybe I make the wiring wrong. Before I release the lab for your guy, on the lab already been tested. Guarantee they're working. You're learning troubleshooting from the basic circuitry. So when more, complicated circuitry, and that you're able to do it. The thing at this time, You get more time. Try to do it. Okay. Try to understand anything you not quite. Go ahead and asking me. I can explain to you. This is very, very important to the technician how to troubleshoot it. Analog circuitry more easier. Okay, any question, anything?
As you say, Mr. Pham, easy.
Okay, so make sure I already given to you, make sure you get it part. I want to see how many people next week showing me your program working.
We copy
see-
off of Adam.
Do you want to see mine, Mr. Pham?
What?
Do you want to see my program?
Okay, I can stop there. Okay, and
Oh, Mr.
I want.
Don't copy and paste.
Get your camera ready.
Let's say go to the top. I want to see your name. Pony. Okay, I know you. You're doing good.
Yeah, he want to make sure it's you.
Thank you.
I want to also I want to see. Let's see. So who else? Kuma.
Yeah.
Next week.
Okay. That's better.
You
I
know.
showed you a little bit today too. I halfway done.
Okay. Now I just want to go to see counting. J equal 1, right? Less than 10 equal. J plus set number. Okay. If J less than 10 and expect data, you want it to be a J. That means apply one clock, they go to 1, 2, 3, 4, 5. However, when they go up to 9, the output you don't want 9 and you don't want 10. You want it to be 0. That's correct. Major data read equal, that's okay. You going little up. Okay. Here. Let's see. You say right port D 0x0F. That means you're loading, right? I want to see on that first, okay? Now, when you start counting up, okay, that means you're counting up right here. Okay, in here you say you clear, A2, A3. Now, clear, go to number 4. You apply 0, 0, 1 here, 0 here. That will be 0, 2. That's to clear, right?
We test 4?
That's on test 4, right?
Yes, sir.
You apply 0, 0, 0, 2.
Yes, sir.
Okay. Now, on your program, you say clear here, right?
Can you see?
Okay. 1F here, you want 0, correct. Okay. Right, port D 02, correct. Apply the clock. Okay, go a little up. No, down.
Oh,
I want to see counting. Up,
oh, down.
that's all. Okay, stop here. So now you say math data 0F, correct. Okay. And P cop, you say U2. That counter, correct. And when you write into port D0F, normally you can add in a comment in here. What you want on 0F here?
What's that?
What that means when you say you want to write to port D0F? Why 0F? What you want?
I want ones at load and clear and also ENP and ENT for counting.
Yeah, perfect. That's what normally you understand myself at work. Every time I wrote it, I say 0F, then I put a comment here.
Okay.
Okay. Why? The thing is, a month later, you're reading the program and you really don't know what you're doing.
Okay.
Okay.
So you saying you wanted him to, if I could just interrupt Adam, you wanted to write a comment? Oh yeah, right there.
Right.
Yeah.
He can say, okay, clear equal 1, right? That's what you want, right?
Yes, sir.
Equal 1, load equal 1. Okay, NP are equal 1.
Oh, ENT and EMP.
Yeah. E and E and T equal 1. Okay.
And that explains how he got 0x0f.
That is normally I did it. Okay. I did it at work. The thing is, 1 month later, when I read in what 0F, I don't know what's going on. However, the comment in here telling me what I did. Correct. Perfect. Okay. And this one, you okay. Going up. Okay. And this one, okay. Report, okay. Now that's 15. Okay. Math data, you want 1, 0. Correct. Expect 1, 0. Pick up here. Write to port D. We not write anything. Right?
Right, because we already have the same conditions.
We just verify the output. And
Yes, sir.
also you cannot put P clock here.
No P clock?
No. Why you get P clock? You can see on here. Okay. When you go to test 15, they already get the clock ready here, right? You see that?
I can't see. Should I stop sharing?
Oh, you stop sharing.
Oh, no. I'm sorry. Where are you having me look here?
The thing is you cannot see
Line 127.
the schematic. What I'm saying here, you don't need that any clock anymore.
No P clock here.
Yeah, they already won.
Okay.
Okay.
And write the port D, he don't need that no more either, right?
We don't have any right to port D anyway.
I had it commented out already. Yeah.
Okay, yeah, I was just asking Adam, no problem.
Okay, that only you make sure you measure they have to be 1, is it?
I'm sorry?
What I'm saying is only the test 15, you want the output of the U3 have to be 1.
Yes, sir.
That's why you just measure.
I see.
No,
It's automatically triggered by the count.
exactly. They
I see.
already trigger it.
Thank you. Okay.
Okay, that's it. Perfect.
Thank you, sir.
Yeah, that's it. I need, 6:30. I need to stop here, okay? We'll see you guys.
Tomorrow?
Tomorrow, Mr. Thai, not me.
You Monday.
Yeah, Monday will be.
Monday, Kumi gonna show you her program.
No,
Oh, this guy the same.
not yet. Monday, prepare for final.
Okay.
Okay. I upload the test number 5 tonight.
And could you please update this recording too, Mr. Pham?
Can you say again? I couldn't follow.
Could you please update the video record of today
Yeah, okay,
Thank you.
we'll do it.
Also send us the answer for the test.
Answer for the test. That means review for the test. I cannot send it this time. I let they do it. Okay,
Okay.
Monday I have to go through that test again, telling you which one right or wrong. And also quick review for what's going on the final.
And the finals on Tuesday. Hang on, Monday. Is Monday?
Now next week final will be on Wednesday.
Is there class on Monday?
Yes.
Isn't it Martin Luther King?
Oh, okay. Monday will be off, right?
Right.
Yeah, Martin Luther King.
Okay, I see that. Okay, so Tuesday will be review.
Wednesday the final, or Thursday?
Exactly.
I
Okay.
think Thursday better.
Okay, I get my class on 19th, 20th. Okay, so 19 will be review the test. Number 5, telling you which one right or wrong. Second thing, quickly review to the test final on Wednesday.
Okay.
Okay, see you guys.
Thank you.
Thank you.
Thank you, teacher.
Thank you, Mr.
Thank
President.
you.